Ooh, aluminum foil. I love aluminum foil. I can make little figurines out of aluminum foil. Ooh, that looks pretty good. What do you think? My little turtle.
Oh, hi, Miss Wirs.
I made a nice little turtle out of my aluminum
Wow,
foil.
that's pretty impressive. Have you been playing with a lot of aluminum foil?
Well, actually, my students are going to be doing a lab about aluminum foil tomorrow.
Oh, that sounds interesting.
So yeah, it's really
Are they
cool.
gonna make turtles or?
They're going to no, actually, they are going to take a piece of aluminum foil
Okay.
and figure out how many atoms thick. That means what I can pinch between my fingers, how many atoms are in that thickness of aluminum. How many atoms of aluminum are in that thickness?
You're kidding me, right? So, okay, we talked last time about how small atoms are, and they're really, really, really small.
Right.
So, I mean,
Really
how could you
small.
possibly, I mean, you don't have a ruler, you could like measure the thickness of that. How
Nope.
could you possibly know how many atoms are thick this thing is?
Well, I do know one thing. I know that in aluminum foil that is this long, okay, now watch how long this aluminum foil is,
That's
right?
about as long as my arm, a little longer than my arm.
In this whole piece of aluminum, there's going to be 6.02 times 10 to the 23rd atoms of aluminum.
6.02 times 10
To the 23rd.
So that's 602 followed by 21 zeros.
Yeah, big, huge number.
Whoa.
And as it's so big that if I had that many grains of sand, that sand would cover the state of California 7 feet deep.
7 feet deep.
That's a lot of sand.
Wow. I wonder about Texas or something.
Yeah, really, I don't know. That's a good question too. But then, if I had that many, 6.02 times 10 to the 23rd basketballs, you would need a basketball bag the size of the moon to fit all those basketballs in.
Wow.
So that's a lot.
That's a big number.
That's a lot. So if that's a lot of atoms, then do you think there's a lot of atoms inside just the thickness of what I can fit in between my fingers?
Let's see here. I mean, there's got to be at least, this is really thin. So I'm saying like maybe 9 or 10. I don't know. It's
Okay.
got to be a small number. Right?
Notice how he's making a hypothesis right now,
That hypothesis.
right?
That's when you get really cold and then
Haha, funny. Well, you guys, the lab that you're going to be doing, the thickness of aluminum foil lab, and your problem is to estimate the number of aluminum atoms that give the foil its thickness.
So you're really not kidding about this. The students really have to figure this out.
Yep.
Okay.
Estimate the thickness, how many atoms are in the thickness of aluminum foil. Okay? So what you guys are first going to have to do is, of course, come up with a hypothesis. Right? And that's our if-then statement. So you've got to come up with a way of estimating how many atoms you think are in the thickness of aluminum foil. So what's your if-then statement going to say? If there are 6.02 times 10 to the 23rd atoms in one long strip of aluminum foil, then I believe there will be blank atoms in the thickness of a piece of aluminum foil. And of course, I want you to make it an educated guess, so make sure that you put in your because. Now don't forget also that from your hypothesis, you should be able to pull out your independent and your dependent variable. Okay? Now, what are some of the things that we're going to use in this lab? So, some of your materials are going to be a graduated cylinder.
So this cylinder made it through 4 years of high school.
Yep. It graduated. Haha. And you're going to have a block that's made out of nothing but aluminum. So instead of it being aluminum foil, it's an aluminum block, still made out of nothing but atoms of aluminum. You'll of course have your piece of aluminum foil. You're going to also need a metric ruler.
Metric, that's only the centimeters.
Yep,
Okay.
centimeters and millimeters. And you're going to need a pair of scissors, as well as a balance.
Oh, okay, and a balance. And that's one of the fancy ones that has a digital readout on it.
Okay.
I still don't know how you guys are going to do this.
These are your list of materials. You have a piece of aluminum foil, a graduated cylinder, metric ruler, a balance, and an aluminum block. So, what do you think, given these materials, what do you think would be the purpose of all these things in here? What can you actually figure out from these pieces of equipment? What are some of the things that pop out at you? Like, what would you do with the balance, Mr. Webster?
Well, the balance, it tells you like how heavy things are, but I guess I remember one of my teachers said that's the mass.
Very
You
good.
got the mass. It's like grams.
Very good. Okay, so you can measure mass with a balance. What else might you be able to measure here?
Well, this is where you put like a liquid in this graduated cylinder, and I use volume, so that's your volume there.
Okay, so you're onto something here. Where does that lead us? If we're doing volume and mass, does that ring a bell of anything that you might?
I don't know.
What does
There's
volume and mass give you?
something if you divide mass divided by volume leads to. Do we let the kids figure it out?
What do you guys think? What do you think mass and volume would usually lead you to?
And then we have a ruler here. That's to measure how long things are.
Mm-hmm.
And then down here at the bottom, we also got some scissors.
Yeah.
So that's for cutting. I know that.
Okay. So scissors. Make sure you include scissors in on your list. Okay. So where's this all taking us? Well, what we're going to ask you to do tomorrow is come up with a procedure on what exactly would I do with these materials in order to find out how many atoms thick aluminum foil might be, or how many atoms are in the thickness of the aluminum foil.